Hello, everyone. Good night. So today we're going to go over our document classifier, which is for our government policymaker. And basically, we're going to start with our agenda right now. We're going to go over with our problem statement. After that, we're going to do a little explanation of the data description and the exploratory data analysis that we perform, along with the pre-processing steps that we follow in order to build this model. After that, we are going to cover the modeling techniques that we utilized and our findings. So let's start. Let's just jump into it, right? So the first is a problem statement. I'm just going to read it briefly to you. So our stakeholder is concerned with interactions on social media related to civil unrest and political protesting in order to identify themes that can inform improved policies and policing, creating policies. We have been asked to explore the existing data set of manually labeled documents to create a document classification system that will let the nonprofit save money by avoiding human labeling and errors, of course, by enabling quicker identification of users and their related text, right? So this is going to be our goal information. So first, we're going to understand the training data sets. For this, we see the already labeled 2,000 documents or tweets. In this case, we see the top frequent words. We have around 9-10 terms, and we right off the bat see two political terms which are very polarizing, which are, for example, Black Lives Matter and COVID as well. We also see some others that may or may not be related, but we don't have context. We're just doing some exploratory data analysis. So we see CNN pop right there. We see MTG, Black, Zombie, Unicorn, and Rainbow. Then we create this dendrogram, which is basically another way of viewing the same data. And then we did some word association for Black Lives Matter, and we see it has a lot of different words that it's associated with. Most meaningful ones are, for example, Black Holiday, Black Lives Matter, Chief Legit, Purposefully, George Floyd, Justice Support. So we see that this is basically protesting about for what happened in that scenario. And we also see for COVID has a lot of different associations. The most meaningful ones are reported new cases, test, coronavirus, and some others which are showing up there. So then we perform a word cloud. In this case, we see we created some bigrams, which is basically joining two tokens into a bigram or a two-word. It's called a bigram, and so we see some of this in the word cloud to drive more meaningful context. So we see that MTG, it's Magic the Gathering. We understand that for people that don't know, that's a card game. We also see some other like Black Lives, Black People, George Floyd, Pride Month, Right Now, Lives Matter, Fly Right, and so that's what we get from here. Interestingly enough, we don't see anything related to COVID in this word cloud. We're gonna see in the other one what we find after we do the same with the train. In this case, with the test data set, which is 1,000 tweets. For top frequent words, which we see pretty much the same ones. Some of them are not showing, and we see less frequency because this is a smaller data set, right? After this, we created the same dendrogram, which is going to show us this in a different way, and the word cloud as well. The word associations as well, which in this case, we see some less words. Some of the more meaningful ones are Justice, George Floyd, I Can't Breathe, George Floyd, and Black Lives Matter protests. For COVID, in this case, we see cases, portability, totals, health, coronavirus, and new, right? And Alaska, which is interesting, probably there was an outbreak by the time we gathered those tweets. And then we see the word cloud right here, which is driving more meaningful bigrams like Antifa, terrorist. We see don't care, rainbow lights, neon unicorn, COVID cases, zombie apocalypse. So COVID's popping up. We'll never see a reporter. Right now, we see some other ones repeating like Pride Month on Right Now, tear gas. Tear gas is new. Black people, group funds, rainbow flags, social media, MTG, Magic the Gathering, and some other ones which were not removed by the clean corpus function or the XBAC. So after we understood a little bit about the context of the tweets, we went into the pre-processing steps. In this case, for pre-processing, we focused on, the XPack instead of the clean corpus, which both are different ways of doing the cleaning for removing punctuation, strip white spaces, make all lowercase. Also with, that's what we did with XPack, but with clean corpus, you could also do some other different sorts of things to clean up the data, like the content transformation to remove URLs, or also add the custom stop words to drive more meaningful words. And for those of you who don't know what a custom stop word is, it's a function in R to remove all the words that are like joiners or that don't drive meaningful things. Or you could also expand that, for example, to remove some of the things depending on your challenge. For example, retweet, which is RT, or ampersand, which is AMP, or LOL, or SMH, or any other of these words which are not going to drive a meaningful value to the modeling. After that, we tokenize, which is basically we break down all these phrases into tokens, which are words, single words. And then we prune the vocabulary to create a lexicon for the model to understand that these are the tokens that he's going to be understanding, or giving them a value or of political or non-political, which is our mission here. And then the vectorizer, for those of you who don't know, again, R. So vectorizer is basically most functions in R are vectorized, which is basically taken then and applying the function to the whole vector, or to this whole column, if you would understand it from an Excel perspective. Whereas some other languages would require you to loop over and over and over the same function. So we vectorized for that, computerly sound way of doing it. And then we created that the term document matrix, which is basically each document is a tweet, and the terms are all these different tokens which we created, right? And so this is the pre-processing step. Now, jumping into the modeling technique, we use the ElasticNet, which is basically a way of doing, well, it's a popular regularized linear regression that combines two different penalties from the lasso regression and the ridge regression. If you're gonna jump into the math, just don't sweat it. But all you need to know, it's basically, using two different penalties or parameters that you can adjust in order for it to be more elastic or not so overfit into a specific way of modeling this data set. The main goal of using this ElasticNet is to avoid the concept drift, which is basically going into that overfitting because models are picky, right? If you have any questions, you can ask at the end of the presentation. But then after that, we modeled, we did the model fit and the train to the trained data set. In this case, we see that anything above 1 or positive, in this case, like CNN, Bunker Boy, Black Lives Matter, Protest 2020, Antifa, and NYC protests are sound, or meaning that they are driving signal to as a political term or token in this case. And with the confusion matrix right now in the first column right here, we have the predictions, and in the second column we have the reference. The zeros are negatives and the ones are positives. In this case, we see that the reference was 0, and we predicted 0 for 1,411, and the reference was positive, and the prediction was positive for 398 of the nearly 400 something, which is a very good accuracy. We see that the accuracy is above 90%, so that's great. But then again, we are also gonna use this, tokenization and vectorizer to basically make a matrix matching of the model, because models are picky, and it will expect all the tokens to be present in the dataset, right? So we call predict to classify the new dataset, and the top 6 calls were true after reviewing that, because we don't have a benchmark to call what are the statistics of the accuracy or the 95% CI or any other statistical value, because we don't have nothing to compare it against, because this is new data that neither the system has seen or has been previously labeled like the other ones, like the training data set. So for the test data set, we can't give you the statistics because this is a real life example and we're doing the modeling technique, right? So, but after applying, you know, the model fit, we went ahead and reviewed what it called as a one. And so, for example, the top 6 calls were for row 12, row 17, 19, 22, and 28. And as a quick sample, we took them over and we inspected the tweets, and it seems that it's accurate. For example, some of them had Antifa, some of them had like, for example, Trump or Antifa again, Antifa, Black Lives Matter, and protesters, CNN. So it seems like all these terms in those 5 tweets seem accurate. And so that's what we can see. However, after we reviewed ourselves the tweets and we read them over, the ones that were zeros, for us to see context here, it seems like this gathering of these 3,000 tweets was by the time that, you know, this there were riots everywhere because of Black Lives Matter, but also because of COVID. And we saw that the White House was, you know, taken over by some protesters. And so that's what some of these tweets referring to zombie apocalypse and this, you know, all of these other things are also related to political discourse. However, they were not picked up as that because basically they were pre-labeled as zeros. And so that's what the model understood, that they were not political. So yeah, that's some of our findings. We didn't perform a sentiment analysis because we don't have a context. However, that would have been a good exercise, not to overstand. We noticed 2 main political discourses, COVID and Black Lives Matter, specifically Black Lives Matter. From the training data set, 40% of the labels we saw 800 something were political or were labeled as political as ones. The model predicted the data and the training data set based on the previous labels. So more context is good for better training of the model. Hope you find this interesting, and thank you. Have a good night.